One.
Nuclear energy. Many people hear this controversial phrase and immediately rule out any potential for nuclear energy without really understanding how it works. This is just based off the stigma around it and the fear of nuclear weapons. I personally like nuclear energy, even though it's overlooked because of the massive potential it holds to enhance all of our lives, you and me included. That's why nuclear is still relevant today and important for everyone to understand. By the end of this presentation, you'll have enough information to form your own opinions. At this time, when our increasing need for energy coincides with a need for a cleaner and safer energy source, we simply can't dismiss any potential options, especially without properly considering them. Nuclear energy, although complicated in composition and science, is easy to understand, and everybody should, because of the massive potential for future use to enhance our society. That's why today I'm going to talk all about nuclear. I'm going to share some information that will help you understand nuclear energy's fundamentals, past, and future for energy use. On a basic level, nuclear energy is simple to understand, but can be extremely complex in practice, requiring lots of resources. According to the University of Berkeley, 95% of the material energy inputs are steel and reinforced concrete. Next come the technical components necessary for a power plant. We rely on uranium-235 as a fuel source. We use water as a moderator to slow down neurons, and we use control rods to control the reaction. The heat produced from the reaction is pumped through a water pressurizer into a steam generator, which then produces steam and spins a turbine to create energy. There are two main types of power plants, PWRs and BWRs. But how do these plants actually produce energy? Well, BWRs and PWRs are slightly different. Pressurized water reactors don't actually boil the water, and they instead pump it to an unpressurized water containment structure, where then it produces steam and powers the turbine. Boiling water reactors, however, as you can see, produce steam straight from the reactor vessel, and this is pumped to the turbine to create energy directly. Uranium is shockingly dense with energy. According to the World Nuclear Association, 27 tons of uranium can produce the same amount of electricity as 2.5 million tons of coal. So how does this reaction actually occur? Well, when uranium-235, or enriched uranium, is shot with a neutron, it can cause the atom to split, which releases energy and more neutrons. This creates a self-sustaining reaction, causing more and more splits, which releases a massive amount of energy. Now that you know about how a nuclear power plant works, let's talk about how nuclear energy was discovered and how it was applied. Uranium was discovered in 1789 by Martin Klaproth, who named it after Uranus. After many more discoveries about uranium, one scientist, Bohr, proposed that uranium fission was much more likely to occur with slow neutrons moving instead of fast neutrons. This can be achieved with a moderator, which is why we use water. Actually, we specifically use heavy water, which is 10.6% heavier than regular water and has a slightly different properties. Heavy water is naturally occurring and accounts for about 0.02% of all natural water. Bohr released these ideas in a paper published only 2 days before the war broke out. Papers and memorandums like this sparked interest in other countries such as the US. Little emphasis was given to the bomb concept until December 1941, when the Japanese attacked Pearl Harbor and the US dumped lots of resources and funding into developing atomic bombs. This US program would cost over $1,000 million, all for the bomb, with no work to applications for energy use. Later on, the first nuclear energy to produce energy was constructed, although it was a trivial amount. This was the experimental breeder reactor EBR-1. The reactor started up in December 1951. Sometime later, in 1986, two historic accidents occurred. The first one was Chernobyl, which was caused by a flawed reactor design and an underqualified staff. 30 people died as a direct result, and more than 350,000 were evacuated. The plant was in Ukraine, and the operators made some key mistakes that caused the reaction. Another major disaster occurred in Fukushima in 2011. The meltdowns were a result of a massive earthquake, which also triggered a 15-meter tsunami, which shut down 3 power supplies and containment structures. The accident was rated level 7 on the International Nuclear Scale. Over 2,313 disaster-related deaths were reported from evacuees. We learned a lot from these disasters, and these events, as well as fears of nuclear weapons, perpetuated the stigma against forms of nuclear. This is a quote from a Stanford paper written by Reagan Williams. The stigma around nuclear energy production revolves around the perceived fallout risk that would seemingly put the country in grave dangers. Disasters such as Chernobyl and Fukushima only perpetuated and discouraged growth in this field, as being the answer to our energy needs. With the technology of today, however, we are better equipped to deal with these disasters and prevent them from ever occurring in the first place. With current technology, nuclear in the US looks a lot different today. Let's take a look at the current state of nuclear energy, its potential for growth and future use, as well as remaining issues. According to the US Energy Administration, in the US, 20% of all electricity was formed via nuclear power. This shows how nuclear energy is still very relevant today. Currently, spread around 34 countries, there are 444 operating reactors, with an energy production possibility of 395,578 megawatts. However, 70% are older than 30 years old, and over 100 are scheduled for shutdown. But more are being built. All of that being said, there are still some issues that haven't been solved, and the first is public uneasiness around nuclear weapons. Many people feel scared of nuclear weapons, and another issue is the spent uranium fuel, which is still radioactive, and we have no long-term solution for getting rid of. And it can't be disposed of in normal ways. More than 250,000 metric tons of highly radioactive waste sits in storage near power plants, and 90,000 metric tons in the US alone. Another issue is the high capital cost associated with nuclear power plants, which discourages investors. The Florida Power and Light Company estimated the total cost of a nuclear power project to be $17.8 billion for two 1,100 megawatt plants. Recently, there's been an uptick in political attention on nuclear energy, with big candidates like Andrew Yang supporting. Andrew Yang said, "To me, nuclear energy needs to be on the table in transition to a more renewable energy source and economy, because our society consumes a great deal of energy." He also said, "And nuclear right now gets a bad rap, in part because the companies we're using are antiqued." Now that you understand the basics of nuclear power, from nuclear fission, nuclear power's current state, and its future potential, while keeping in mind the historic disasters, you can make your own opinions without any bias or stigma affecting them. I will leave you with this. In this world where In this world with growing need for clean energy sources and recent political interest in nuclear power, it's important to understand the options. Don't be surprised in a few years if a nuclear power plant pops up near you. Thank you.